Welcome back. Today I want to introduce functions in Python. So let me just start with an example. So for instance, assume we want to do a function which takes an integer to the power of another integer. How could you do it without using any function? We can just simply now start assigning values. So for instance, I can assign the value 5 to x, and a could be, for instance, 3. And then we have a result which I might then refer to mx to the power of a. And then here we might do a print function. We can do it fancy, so using a formatted string and using the placeholders. So we can say x of a. We see now we have three objects created. They're of course all integers. So we start a function using the def for define keyword, and then we name the function. For instance, power, open close brackets, colon, indentation. So now we are inside the function. What we would like to do is we would maybe like to simply replicate what we have done here. So we simply execute the same code, and then we do a print statement at the end. Yeah? We just do this inside the block. And now we have it. We have our function specified. I'm not just running the script one more time. Well, nothing happens. Yeah? Nothing happens at all. What you need to do is you have to call the function or invoke the function. So how to do it? We simply write here power, open close brackets. Yeah, so this is calling the function. So here we are, and now it works. Yeah, 5 to the power of 3 is 125. So that's pretty nice. First of all, what's happening here? Why don't we see the x and the a in the result anymore? It's all gone in here. The reason is that these variables only exist inside your block or inside the function. So they have what you call scope, which is kind of tidy because very often you don't want all of that created. You just want to do the computation, but in the end you only want to have a certain output. In our case, we just want to have something printed to the terminal, for instance. The next thing is, at the moment, it's not massively useful because we still do some hard coding. So we hard code the values into the function. The alternative, which is of course the right way to do it, is to use arguments. So in the brackets you can specify arguments. So for instance, I can put the x and the a up here, which means I can remove them inside the function. Now it would take values x and a from the arguments. So of course, if I run it now, I will get an error message because I expect now 2 arguments and none are given. So you will get an error message. We just see how that looks like. So of course you get a type error, so we are missing 2 required so-called positional arguments. Now there are 2 ways to give arguments. One is by position. So for instance, I can simply now put in 5, 3, which simply refers to the position specified. So the first entry will be the x, the second entry will be the a. An alternative way to do it is to use the keywords. Yeah? So for instance, I could do something like this. I can say, for instance, here a is equal to 3, x is equal to 5. And basically switch around the position, but now I indicate my position using the keywords. So that's an alternative way of doing it. It is exactly the same output as before. Yeah? So you can either use positional arguments or you use the keywords, but you can't mix and match, okay? So you have to use either or. You could also assign an output variable. We can do something like this. Output is equal to this power function. Yeah, you can do that. Now let's see what happens if we now want to print the output. And now you get here the output none. Now this is of course what you would expect because this function here doesn't return anything. So what do we mean by this? It basically means that whatever we do inside the function leads only to a printed statement, but we don't return our result. So because result doesn't have global scope, it's not there. Yeah, so we can't use it, but if we want to use it for further work, we have to return it. So what we do is we do a return statement. So you just use return, another keyword, and we can, for instance, return the result. So in this case, we would get the result printed. Yeah? If we now just comment out these two calls and just use the call here where I assign the function to the out variable, I get the following. I get, of course, my function, it runs, so I get my printed statement, and then I get my output, which is 125. Okay, let's do a coding challenge. You have to write a function that asks for user input. Users should input integers, and the function returns the sum and the product of all integers entered. The process stops when the user enters 0. Now first, we know of course already how to get user input. We use the input function. We can assign the input to any object we want. So we could do something like the following. We can specify num for the number, the integer, is equal to input, which we covered in the previous video, and then we can say what we want to say here. So please enter, if I can spell it, enter an integer, enter 0 to stop. Then we give a bit of space, so we could do that, and of course by default this number would be a string. We discussed this, the input function always is a string. So to get the integer, we would have to do the following. We could reassign it using the int function and put in as the argument now our input num. So that would do it. Yeah? I'm not just commenting all of that out. Yeah? We don't need that anymore. And we just start experimenting a bit and see what happens. Yeah? Good, here we go. So here you see, please enter an integer, enter 0 to stop. So we just not test, so I just put in 5. Yeah, and of course that works fine. So that's alright. Yeah, let's run it one more time. And of course now, what happens if I don't put an integer? I just put in some gibberish. And of course I get a value error. Yeah, so because that's not, I can't use the int function here because obviously that's not a meaningful entry for an integer. How can I handle this? Yeah, so ideally when you write a function, you want to handle these exceptions. Yeah, so now you learn one more thing, and that is actually exception handling. So how can you do this effectively? Now what we can do is the following. We can use try except. So you can do the following. You can say try a column and then using indentations inside the block. So what it basically does is it asks Python, hang on, let's try to convert this input into an integer. If it works, great, we do it. If it doesn't work, we do something else. Yeah, so here we can use an except statement. Again, we use the colon here. And here we would simply then print something like invalid input. Yeah, so we can do something like that. Yeah, so if we run this one more time, again, if I enter a normal integer, it should work. If I enter some nonsense, it just gives me now invalid input. Yeah, so you don't have an error message anymore. Actually, I specify now the error message. So that is very nice. The try except is very useful for exception handling. It does not go back and ask me again. Yeah, so we have to think about this as well. So what can we do? The nice thing to do here is to think about a valid or invalid input measure. So I can specify a boolean, which we also covered, of course. I just call this invalid input. If I can spell, I can't today somehow, too many coffees. So initially I would set this invalid input as true because I haven't specified anything. I move this whole block into an indentation, so another block, and I use a while loop. So while invalid input. So while this is true, it keeps running. Yeah, so we keep running, colon here. Of course, if I put in the correct statement and this try works, I have to now change my invalid input. So what I do is I just reassign invalid input to false, which will stop the while loop. Otherwise, it would continue. Yeah, so that should do it. So I'm just running it now. I put in some nonsense, and again it goes back. It will ask me again. I put in some more nonsense. That's fine. I put in a 7, and it continues. And of course now nothing happens anymore, so it stops. Now this actually here is, you could see that as already part of my solution, because this little code will ask for user input and will only stop if the user gives correct input. Okay, it might be useful to actually define a function. And we could, for instance, call this function user input or input number or whatever I want to call this. I just use open and close brackets. I don't put any argument here because I ask for input. I use indentations on inside my function. And what do I want to return? That's the interesting question. So as a return value, I want to return, well, my number. Yeah. So if the number is provided, I want to return this number. So it's very useful quite often to split up this more complicated function maybe into 2 or maybe 3 functions. In general, it's a very good idea to build smaller things, yes, smaller functions that are focused on one problem. Don't try to handle too many problems in one function. Okay, so the next problem is now how can we keep adding these numbers and also returning the product of these numbers. So how can we do this until someone says 0? Yeah. So the obvious thing to note is when you look at this number input, if you think about this, once it's 0, it's actually false, because we talked about this when we talked about booleans. Any integer except 0 is true. Yeah, it's about being truthy or falsy. Yeah, so 0 is falsy. So what we could do is we can use another while loop. So while our number we input, yeah, so we could here simply do this, and we can assign the number from our input number function. Yeah, so we call the function which we just defined here, and we then have our number. So now how do we handle the sum and the product? Now for the sum, I would simply start at 0 and would add up. Yeah, so we can do something like this. So every time we go into this loop, we would start adding up the numbers. So it's a bit like the following. It's plus equal to number. And again, we have seen this before. Plus equal to is basically adding something to an existing sum. So that's a shortcut version. So if you do a plus equal to b, it's a equal to a plus b. Good, so that would in principle do it, and then at the end of it, it would return the sum. Yeah, so we could, for instance, at the end of it do a print statement here, do a formatted string, where we say the sum of integers is whatever that is, some number. Okay. So that would be in theory workable. However, as you can see, we only have now one number here given. Yeah, so we get one number, we go into this loop, and that's it. We don't ever update that. Yeah. So that's not the way to do it, because we already spoke about the problem of, well, the possibility of infinity, to reach infinity in while loops if you don't change these inputs. So basically what we need in here is we have to reassign. We have to keep reassigning. So we need this line in the while statement. So every time you provide an input, we check, is the input a 0? If yes, we stop, otherwise we continue. So now we get a question. We put in nonsense, we will be asked again. I put in an 8, it continues. I put in a 7, I put in a 2, I put in a 0, and it stops. Yes, it does work actually. The next thing is we need the products. So we need the product of this number. Of course, when you do products, you should not start at 0. Otherwise everything will be 0, because you multiply with 0, it should be 1. So this is a little trick for our friends of mathematics. Yeah, so here we do the product underscore number, and this is multiply equal to num. So it's the same logic, the same principle. And in here we do another print statement. The product of integers is whatever this is. Product integers. Okay, so again I put in a 7, I put in a 3, I put in a 2, and then I put in some nonsense, it goes back, I put in a 0, and it stops. Yeah, that looks good, that looks meaningful, so we actually have done it. Yeah, this was actually our objective. So that's quite useful. Now, of course, we haven't written this in a function. Yeah, so this here is not written in a function. This first function is absolutely fine. So now what we will do is we move it all into another function. And I just call this function the sum product function. Again, I don't need arguments because I ask for user input. And I just run it one more time. As you will see, nothing happens because now we have to call this function. Yeah, so now we call the function, and now we have a nice function that exactly does what it's supposed to do. And we don't have any return values. We can think about this in a minute. But we have the output printed. So here again we do some numbers. We can keep going here, and 0. So here we are, and it's all looking good. Right, so the only thing we could consider if we want to, we can have here a return value. The thing is, we have two outputs. We have the sum and we have a product. So how to return this? We can return as a tuple. Yeah, so we can do something like this. So sum number and product number. So we have it as a tuple. Then we could also move out the print statement. Yeah, sometimes this would be maybe useful to move out. It's up to us how we do it. So we could comment this out. So that would be a possibility. So now we would actually have here our output, which would be a tuple. And then we could do our print statements differently if we want to. We could now refer to our tuple and use indexing. Yeah, tuple positioned 0 would be the sum, and the tuple position 1 would be the product. Yeah, so that's an alternative way of implementing it. And now you have the same kind of output. It's just now slightly different because now you see we have the out variable, which is a tuple. Now that's all for this session. I see you in the next